Hey guys, let's take a look at section 5.7 on Achieve. Fantastic section to work. So this is where we start our integration by substitution techniques. They start off with a question here showing you area under the curve x times x squared plus 1. So when I'm looking at this here, I can drag the point to get the area under the curve starting at 1. And obviously if you don't give it any region, if you try to evaluate the integral from 1 to 1 of x over x squared plus 1, you get a 0 area, of course. If you don't give the area any width, then you cannot accumulate area. But as I increase the x value there, it's showing me what the area is going to be. So if I go from 1 to 1.1, it's telling me that the area is approximately 0.01 after it goes through this integration. When I go from 1 to 1.2, it's 0.099. Then if I go up next, 0.148, all the way up till I get to the maximum value of 5 here. It is wanting us to estimate the area from 1 to 5. And it's saying that it's approximately equal to 1.282 for that entire region. Now, if I scroll down through here, and it's saying when the movable point is in its farthest right position, in other words, notably when x is 5, the shaded area is 1.282. And what does this area mean? So when you're thinking about what that area means, it tells you right here before, this is the area of this function evaluated from 1 to 5 of x over x squared plus 1. They had to use substitution and say, let's let u equal x squared plus 1. So du is 2x dx. And so the integral became 1/2 the integral 1 over u du. We had to also change the limits of integration. You can see where they did that here. U evaluated at 1 as 1 squared plus 1 is 2. And U evaluated at 5 gives me the 26. So it's 1/2 the integral from 2 to 26 of 1 over u du. And when I see what happened here, that's going to be 1 over 2 natural log of 26 minus 1 over 2 natural log of 2. Okay, so if I were to combine these two within the same one, it'd be 1/2 the natural log of 26 over 2. Think about where that 26 is coming from. It's just 5 squared plus 1, and of course the denominator 2. That's going to be this third choice right here. It's 1/2 the natural log of 5 squared plus 1. That'd be the natural log of 26. Divided by 2 is going to give me minus the natural log of 2. Both of them are multiplied by 1/2. Has to be this third choice there. Kind of a strange question, really, the way that they have it worded, but that's what they're wanting. Yeah. Up next, for the second question, still the same graph. And it says on the given interval where you're starting at 1 and going up to some number b, where b is some value between 1 and 5, what is true about the area function? Remember, the area function is going to be represented by the integral from 1 to any value b. And we know that this area, which would be represented by the integral, as b is increasing, well, the area is going to get larger and larger and larger. As I make it larger, the area gets larger. So I know that the area is increasing. Now let's see, there's 2 in which it says the area is increasing. So the first one says that the area, it is always increasing at a decreasing rate. That's true. The area is increasing, but as x goes on, I'm adding less and less and less area to it because the height of the curve is getting smaller and smaller. So even though I'm adding more and more area, I'm adding area at a slower and slower pace. So I'd say it's the first choice. Now, why is it not the other choice where it says the area? So clearly the area is not decreasing. So those that say decreasing just make no sense at all. But the third choice there says it's always increasing at an increasing rate. No, that would mean not only is the area increasing, but the rate at which it's increasing is increasing. That would be if it were the reverse of what's happening. It would be if it's an increasing function. It's not going to happen here. So has to be the only reasonable choice is the first one. We'll select that. Yes. Now, let's look at the first of our problems that actually ask us to do some manipulations ourselves. So here's my work that I did for number 3 here. Number 3 asks us to integrate the integral 4x minus 5 quantity cubed with respect to x. And this is just the general antiderivative, so we'll have to remember to put the plus c in there. Now, whenever it says absorb as much into c as possible, we won't really have to worry about that too much yet. Where that comes into play is if you have something like the natural log of x divided by 2, you just go ahead and say that that's the natural log of x, because the natural log of x over 2 means the natural log of x minus the natural log of 2. And then you can say, well, that natural log of 2 is just a constant. It would get absorbed into the constant of integration. Most of the time, you're not going to see that occur in the problem. But I just wanted to kind of mention what they say when they say absorb into c as much as possible. That's going to come into play later, more so than it will in this section. When I look at this first problem here with you, we have 4x minus 5 cubed, and we're trying to integrate that. Well, they tell me to let u equal the 4x minus 5. So when I do that, I can say, well, if u is equal to 4x minus 5, then the derivative of u is going to be 4 with respect to x. Remember, du dx would be 4, so du is 4 times dx. So I need to see that 4 dx in the problem in order to carry out the substitution. So I only saw a dx in there. I'd go ahead and make it 4 dx. But if you multiply by 4 on the inside, then you're going to have to make up for that by dividing by 4 on the outside. So I have 1/4 the integral 4x minus 5 cubed times 4 dx. Then I can say, well, then this is going to become 1/4 the integral. The whole point to doing this was to put it in terms of u. We can do that. That's going to be u cubed, and then the 4 dx becomes our du. Now, the integral of u to the third with respect to u, we use the power rule. Remember that 1/4 gets carried along. And I can say the integral of u to the 4th power over 4, which is going to give me 1/16 u to the 4th. Well, now I substitute back in u to the 4th is nothing more than 4x minus 5. So I get 1/16 times the group 4x minus 5 raised to the 4th plus that great constant of integration. We'll check this out here. I have the 1/16 times the group, and then it's 4x plus 5. Minus 5. Make sure I type it in rightly. And I'm going to raise that to the 4th power plus the constant of integration plus c. So now when I check that answer, as you can see, it is correct. I'll go on to the next question here. For it, we're supposed to, it says write the integral in terms of u and du and evaluate, and I have the integral of t on the square root of 5t squared plus 3 integrated with respect to time, with respect to t. And it's telling you to let u equal 5t squared plus 3. So with that substitution in for u, then when I try to find du, I can just say, well, it's just the derivative of that, which is going to give me 10t with respect to t. But I don't see the 10t dt in there, so I had to multiply by 10 on the inside, which means I had to divide by 10 on the outside. So now I have 1/10 times this integral. The 10t dt becomes du. My square root is going to become the square root of u. So I have 1/10 times the integral of the root of u times du. Now, I know that this is the same thing as u to the 1/2 power, so whenever I integrate that, it becomes u to the 3/2 power. Then I divide by that new exponent, or I would rather multiply by its reciprocal and get 2/3 u to the 3/2 plus c. Now, from here to here, I'm just simplifying. I know that the original was written in radicals. I would prefer my answer to be in radicals. So I'll say this is the square root of u to the third power, and it's being multiplied by 2 over 30, which reduces down to 1 over 15. So I can just say it's the root of u cubed over 15 plus c. Now, that's not our final answer, so that one shouldn't be circled, but our final answer is when you put it back in terms of the original variable. So in the place of u, we have to replace it with 5t squared plus 3, and I should be getting the square root of 5t squared plus 3 quantity cubed over 15 plus the constant of integration. Now, I'll need to use the palette within Achieve to help me on this one. First, I have a fraction, and then I have a square root, and it was the square root of the group 5t raised to the second plus 3, and then I had that group raised to the third power, and then all of this was divided by 15, so I go down to the denominator, divide by 15, plus the constant of integration. Now, I want to make absolute certain that that is exactly what I had. Square root of 5t squared plus 3 cubed, all over 15 plus c. Glorious. We go to the next question because it, oh, no, I don't. Let's see what's going on here, guys. So I do not think I've done anything wrong. The square root of 5t squared plus 3 cubed all over 15. That is a fantastic answer. Let me show you something that I think Achieve is bad about sometimes. They're not very accepting of different formats of answers. I am 100% certain this answer is correct. Well, what's wrong with it? It's probably wanting me to put it in a wussy fractional exponent. So let me go ahead and do that. So again, I am confident that answer is correct, but here's what they're going to want here. They'll say 1 over 15, and then I'll have times the group. It was 5t squared plus 3, 5t raised to the second, not to the 22nd, plus 3. And that's close out that group. And then I want to raise that group. It was inside of a square root, but then cubed. So it's to the 3 over 2 power. So I'll raise that to the 3 over 2 power plus c. This should be what they want. We'll check that answer. Now, again, the answer I had is superior to this answer, but quite often, see, that's frustrating. Quite often, that they'll want the inferior notation. So the general rule of thumb is whatever format the original problem is in, you want your answer in that format. But in order to get Achieve to accept my answer, I had to put it raised to the 3 over 2 power. Just beware, that's going to happen sometimes. It's not that you're doing the problem wrong, it's just that it doesn't like the form of your final answer. It should accept both answers in that last problem, but it doesn't. The next one here, number 5. So it says to write the integral t cubed over 5 minus 6t to the 4th raised to the 11th power in terms of u and du, and then to evaluate it. Okay, no problem. So we'll go through and say, well, u is just the denominator, 5 minus 6t to the 4th power. And so now when I take the derivative, I'll get negative 24t to the 3rd power with respect to t. I know that I don't have the factor of negative 24 inside the group. I have the t cubed. So I need to multiply by a negative 24 on the inside. If you multiply by a negative 24 on the inside, then you divide by a negative 24 on the outside. Now, when I do that, this is going to be able to simplify the problem to negative 1/24 on the integral. This negative 24t cubed dt, all of that's going to become du. So I get 1 over, my denominator is u to the 11th du. Well, now I can say this is the same thing as the integral of u to the negative 11th. When I integrate that, I'll get u to the negative 10th over negative 10 plus c. And then I can say, well, that's just going to give me negative 1 over 24 times negative 1 over 10. That's a positive 1 over 240. And I know that the u belongs in the denominator to the positive 10th power. When I put that into terms of t, I'll get 1 over 240 times the group 5 minus 6t to the 4th raised to the 10th plus our constant of integration. So this one shouldn't be bad at all. 1 over 240. And we have times the group 5 minus 6t raised to the 4th. We'll close out that group, and then we know that group is raised to the 10th power in the denominator. Then we'll arrow over plus the constant of integration. Gorgeous answer. And we got it. Up next, we have to evaluate the integral of x times the group x plus 1 to the 5th power with respect to x. So just as they say, whether or not they gave the hint there, you would let u equal what's inside of the group to the power. So u is going to equal x plus 1. Then as soon as I realize u is x plus 1, then I can say, well, then du is going to be dx. Now I'm going to have an x in there that doesn't get canceled with a substitution, so I would have to account for that. Well, if I know if u is x plus 1, then solve for x and say x is going to equal u minus 1. Now I go back into my problem. X, I replace it with u minus 1. X plus 1, I replace with u, so I have u minus 1 times u to the 5th du. At first glance, someone might think that they're not any better off here than they were here. We're so much better off. Here I could not algebraically simplify before I took the integral. Here I can. I can distribute that u to the 5th through that group and get u to the 6th minus u to the 5th. Now we'll use the power rule to integrate. First term becomes u to the 7th over 7. The second one, u to the 6th over 6, plus our constant of integration. So now when we put that back into terms of x, we can say, well, we're going to have the group x plus 1, and that's raised to the 7th power, and then divided by 7. And I'll say minus the fraction again, I'll have the group x plus 1 raised to the 6th. And then I'll divide that group by 6 plus the constant of integration. And that should be what they want. Yes. For the next question here, number 7. We have, the Facebook messages. For number 7 here, it says, we're supposed to be integrating in terms of u and du. I have the integral of 10x e to the negative x squared with respect to x. And they're telling me to use the substitution. And again, we should know to use this substitution whether they ask us to use it or not, of u is equal to negative x squared. So whenever I do that, I know that the derivative of u is just going to be negative 2x with respect to x. So then I can say, well, okay, once I do that, I look in my problem. Now this one's a bit tricky because I need a negative 2x dx in there, and I have a 10x. So what I thought, well, 10x is the same thing as negative 2x times a negative 5. So I broke it apart and said 10x is equivalent to negative 2x times a negative 5. I need the inside to have the negative 2x dx. Well, then the outside has to be a negative 5 if I do that in order to force my substitution in this problem. So I factored a negative 5 out in order to make that 10x a negative 2x. Now I carry out the substitution. The negative 2x dx becomes du. My e to the negative x squared becomes e to the u. And then I know that the integral of e to the u is just e to the u plus the constant of integration. I have my -5 multiplied out front. My final answer, -5 e to the negative x squared plus that glorious constant of integration. And then plus c. Should be final answer there. We'll check that one. And it is. For the next one here, number 8. This one's actually pretty quick and pretty easy. We have the natural log of x raised to the 9th divided by x, and we're integrating with respect to x. Whether or not they told you, we should know that that what's being substituted here is going to be u is equal to the natural log of x. It's a wonderful substitution because when I do that, the derivative of the natural log of x is just giving me 1 over x with respect to x. So then I can say, well, all right, that's already in the problem. 1 over x dx is already there. That's going to become du. When it does, your denominator cancels out. So this numerator, natural log of x to the 9th, just becomes u to the 9th. Now it's just power rule. We'll get u to the 10th over 10 plus the constant of integration. And then when you back substitute, we know u is just the natural log of x. Now, one thing I do need you to remember here, while you're working throughout the problem, you don't need parentheses, and you really never need parentheses around the argument of a logarithmic function. You'll have to have parentheses around the argument of a logarithmic function for your final answer within Achieve. It's just one of the things that their platform requires. So now when I try to put my final answer in, I'll say, well, it's going to be the group, and I'll have the natural log, and notice it automatically opens up a parentheses. So natural log of x, I'll close outside of the argument, go outside of the natural log and say that's raised to the 10th power. And then we had all of that divided by 10. So the natural log of x raised to the 10th over 10 plus our constant of integration. And that should be exactly what they want. It is. For the next one here, it's asking us to evaluate the integral of x to the 14th times the cosine of x to the 15th. Okay, so if I'm looking at that, and this time it's one of the first problems that they don't tell you what to use as the substitution. In this case, the substitution, the problem with this is the angle inside the cosine function. I know what the integral of the cosine of x is, but I don't know about the cosine of x to the 15th. So I'll let u equal x to the 15th. The derivative of u is going to be 15x to the 14th with respect to x. So then I can say, all right, I don't have a 15x to the 14th, but I can put it in there. So I have to multiply by 15 on the inside, divide by 15 on the outside. I'll get 1/15, 15x to the 14th, cosine of x to the 15th dx. That 15x to the 14th and the dx all becomes du. So the only other thing I have is the cosine of x to the 15th, which I know is just going to be the cosine of u. Now, I can integrate the cosine. I know that the integral of the cosine is going to take me back to the negative of the sine function, or sorry, back to the positive of the sine. Derivative of cosine is negative sine. Integral of cosine is positive sine. Got to keep your signs right there. Now I'll say integral of cosine is sine of u plus c. And then whenever I back substitute, the u is x to the 15th. We'll get 1/15 sine of that angle, which is x to the 15th, plus your constant of integration. So 1/15 sine, oh, no. 1/15 times the sine of x to the 15th power, x raised to the 15th. And I'll get out of that angle plus our constant of integration. Nice. Absolutely. For the next question here, number 10. It gives me the integral of 3x plus 13 raised to the 8th power. So I'll just go in and say, well, all right, I know that I have a group to a power. I'm going to go ahead and let u equal what's inside of that powered group. So derivative of the inside 3x plus 13 is just going to be 3 with respect to x. So I know if I'm going to use substitution on this, I need to see a 3 dx in the problem. I don't see that. Well, then I'll go in the inside and multiply by a 3. But if I do that, I have to make up for it and divide the outside by 3. So I get 1/3 times this integral. Now from this step to this step, the 3 dx gets replaced with the du. My group to the 8th power, well, that becomes u to the 8th. Now, the whole purpose of substitution is to take a problem that normal rules don't apply and create a problem where normal rules do apply. It's just power rule now. So the power rule on u to the 8th becomes u to the 9th over 9 plus your constant of integration. We distribute through the 1/3 to get the group 3x plus 13 to the 9th over 27 plus your constant of integration. And I'll say, okay, the group 3x plus 13, and we have that group raised to the 9th power. Then we're going to divide that by 27 plus your constant of integration. Absolutely. And number 11 here in this section. So for this one, we have the integral of 7x plus 1 over the group 7x squared plus 2x raised to the 4th power. So your choice for u almost always is whatever is the innermost part of your function. In this case, I have a group inside the 4th power of the denominator. I'm going to let u equal what's inside of that group, the 7x squared plus 2x. The problem with that is when I take the derivative to find du, I'll get 14x plus 2, and that's going to be all multiplying dx. I really should have a parenthesis around that, like I do, times the dx. It shouldn't just be 14 plus 2 dx, because this is a height times a width there. Now, when I'm looking at that, I have to notice, well, I almost have that in my problem, and I can see that if I factor a 2 outside of that group, I'll get 2 times the group, 7x plus 1 dx. Then I can say, well, okay, since I need a 2 times the group 7x plus 1 dx, I can go into the inside and multiply by 2 in order to obtain that. That's going to ensure that substitution can be done. But in order to multiply the inside by 2, I need to divide the outside by 2. So that's going to give me 1/2 the integral. All of this numerator and the dx becomes du. And then my denominator is just u to the 4th. So I have 1/2 the integral of u to the -4 du. When I integrate that, I'll get 1/2 u to the -4 goes to u to the -3 divided by -3 plus the constant of integration. Now I can go in and say, well, all right, when I'm integrating this, I'm going to call this 1 over -6. I'd rather call that -1 over 6, and then I'll put the u to the denominator to the +3 power plus the constant of integration. And then we can say, well, when we back substitute, that's just going to be -1 over 6 times the group that u is equal to, the 7x squared plus 2x, that group raised to the 3rd plus c. So now trying to enter that in, we'll have -1 over, and now in our denominator we have 6 times the group of 7x to the 2nd plus 2x. And then we know that that group is raised to the 3rd power. And then we have plus the constant of integration, should be precisely what they're looking for there. And it is. Okay, up next here. For number 12. This one's actually a quicker problem. We have the integral of x over the square root of x squared plus 9. So I'll let u equal what's inside of the group in the denominator, the x squared plus 9. When I do that, I see that the derivative of u, derivative of x squared, is 2x with respect to x. I have to force my numerator to have a 2x by multiplying by 2. Thus, I divide by 2 on the outside, or multiply the outside by 1/2. So now I'll have 1/2 the integral of 2x over this square root of x squared plus 9 with respect to x. That's going to give me 1/2. Now this 2x dx all becomes du. Then I would have 1 over that square root of x squared plus 9. That's 1 over the square root of u. That's the same thing as u to the negative 1/2 power. Remember, the square root is the 1/2 power. The fact that the square root is in the denominator means it's u to the negative 1/2 power. Now we have to use the power rule to integrate this. I'll have my 1/2 out on the front, and then the integral of u to the negative 1/2 is u to the negative 1/2 plus 1 goes to u to the 1/2. If you divide by that new exponent, division by 1/2 is the same thing as multiplication by 2. And then I'll say plus the constant of integration. I have to see that those coefficients just cancel out, and I'll get u to the 1/2 power, which is just the square root of u. The square root of u plus c is the best answer. In radical format, it should be the square root of x squared plus 9 plus c. Now, I always worry whenever answers involve radicals because I don't know whether Achieve is wanting the radical or the fractional exponent. They should want a radical in this since the original was in terms of radicals. So I'll put my answer as the root of x squared plus 9. So I have the square root of x raised to the second plus 9. And then we had that plus the constant of integration plus c. We'll check that answer, and they like it. Okay, now this next one is getting into where they're going to have a video example here for us. And I don't know why before every one of their video examples, they go back and make sure you're good with your algebra. So this is just a basic distribution problem for algebra. So they have us multiply 4x to the 4th plus 3x squared plus 9 times the group 5x squared plus 9. So when I'm multiplying that out, I'll get my 20x to the 6th by multiplying these. When I multiply the 4x to the 4th times 9, I get my 36x to the 4th. Distribute through the 3x squared, you'll get 15x to the 4th plus 27x squared. Distribute through the 9, and you'll get your 45x squared plus 81. Collecting like terms, you have 2x to the 4th terms that'll combine to give you 51x to the 4th, and 2x squared terms that will combine to give you 72x squared. Of course, the 20x to the 6th and the 81 didn't have like terms. So now when we go down here, there's only one answer. Obviously, like what we want, it's the second choice on mine. I'll check that answer, and it says good. Now, moving on to the next one here. This one should be, again, quick and easy, but it is important. Sometimes students forget their exponential operations and laws. So when I'm asked to determine the missing expression on the right-hand side for each exponential law, okay, if I have b to the x plus y, I know that anytime I'm adding in the exponent like that, I could separate it up and say that that's the same thing as b to the x times b to the y. So I worked that right here, b to the x plus y, same thing as b to the x times b to the y. If I divide, that's the same thing as subtraction, b to the x minus y. If I have a power to a power, that's when we multiply, it'd be b to the xy. 1 over b to the x, that's the same thing as b to the negative x power, and b to the 0, any number to the 0 power is 1. Now, so matching these in here, b to the x plus y, that's our b to the x times b to the y. B to the x over b to the y, that's our b to the x minus y. Power to power, we multiply those exponents. the negative exponent rule, 1 over b to the x is b to the negative x, and any number to the 0 power is 1. Done. Check that answer, and of course it's right. Now, this one, we've already worked a few of the problems that will entail some problems similar to this one, where you're having to get rid of some terms in order to do the integration, but they have a very good 2-minute video example here of the root of x on the square root of 4x squared minus 5 with respect to x. Probably should go ahead and watch it to make sure you're very good with all the rules. I'll just do that and go on to the next question here. In that next question, they're having a very good follow-up to that one and asking us to use the substitution method to evaluate the integral of y squared over y plus 4 to the 6th power. Of course, we're integrating it with respect to y. So when I'm thinking about how to do that, this is the work that I showed in order to do it. I have the integral of y squared over y plus 4 to the 6th power dy. I let y equal the denominator, y plus 4. But the problem with that is du is just going to be dy. So that y squared doesn't get canceled out in the substitution process. You have to force it out. So here's how I force it out. I said, well, if u is equal to y squared plus 4, then that gives me an equation for y in terms of u too. I can say y is equal to u minus 4. Then if y is equal to u minus 4, then I could square both sides and say y squared is just u minus 4 quantity squared. U minus 4 quantity squared is going to be u squared minus 8u plus 16. If you have any problem getting that, please FOIL out u minus 4 times u minus 4. Don't be the student that thinks that this is equal to u squared plus 16. There's always a middle term there. Now, when I go back and to my problem and try to simplify this, the y squared in my numerator, I put its equivalency in terms of u, the u squared minus 8u plus 16. My denominator, I already know that's going to be u to the 6th. With respect to u, now I'm integrating. So when I'm integrating with respect to u, now I can simplify algebraically. This u to the 6th divides into every term in the numerator. I'll get that this is the integral of u to the negative 4th minus 8u to the negative 5th plus 16u to the negative 6th. Use the power rule on each one of those and add 1 to the exponent. We'll get u to the negative 3rd over negative 3 minus 8u to the negative 4th over negative 4, and then plus 16u to the negative 5th divided by negative 5 plus your constant of integration. I almost ran out of paper there. Now I come down, I can say, okay, well, what's this first term? I know it's negative. So negative 1 over 3 times u cubed becomes times the group y plus 4 cubed. Then I'll have this going to be plus 8 over 4 is plus 2 over u to the 4th, which becomes y plus 4 to the 4th in the denominator. Then we'll have minus 16 over 5 times u to the 5th, or times y plus 4 to the 5th, plus your constant of integration. So now, in answering this problem, it says identify the composite term. Okay, well, u is equal to y plus 4 in this problem. And then it says solve out for what that integral is equal to. Well, that's what we've just done here. I got this answer, so I'll type that in. It's my negative 1 over 3 times the group y plus 4, and we know that that's to the 3rd power. And then we have our plus 2 divided by, and we have our y plus 4 raised to the 4th. And then finally, we'll have our minus 16 over 5 times the group y plus 4. And that's raised to the 5th. Plus our constant of integration should check out just fine. Oh, let's see here, guys. So -1 over 3 times the group y plus 4 cubed. Yes. Plus 2 over the group y plus 4 to the 4th. Yes. Oh, then it's my third fraction there. So nice thing here. So this one was on me, but we can fix that. All you got to do, I had a mistype there. That's 16 over 5 times the group y plus 4 to the 5th plus c. Check that answer. It's right. Haha. Last one for this video I'll be looking at with you is number 17 here. It's a very quick problem. We have the integral of dx over x plus 3 to the 8th. Notice what I did here. I said, well, okay, let's let u equal what's inside the group to a power. It's the x plus 3. If u is x plus 3, then du is just 1 dx. So I can say the dx becomes du in the problem. I would have 1 over x plus 3 to the 8th, which becomes 1 over u to the 8th. I would rather call that u to the negative 8th. That enables me to do the power rule pretty quickly and say that's going to add 1 to the exponent, u to the negative 7, divide by that new exponent of negative 7, plus our constant of integration. So the final answer is -1 over 7 times the group x plus 3, since u is x plus 3 to the 7th, plus c. Final answer here, we'll have our -1 over our 7 times the group, x plus 3, and we have that group raised to the 7th power, plus our constant of integration. Final answer. All right. So now, for the rest of the problems in this section, I'll do in another video. So this should get you through problems 1 through 17. Please let me know if you have any struggles whatsoever. This is a very important section. I want to make sure that you're comfortable and confident with your ability to do it.